So in this short lecture, what I want to talk about is what are the actual design goals. Um, the design goal in a structure doesn't matter what we are designing. There are two alternatives. First, the alternative can be where your material, your sizing, boundary condition, and loads are basically all set. So those are given to you, and all your task is to find your factor of safety. So as we spoke in the last class, you just want to see if your factor of safety is bigger than 1 or equal. In such case, we know it's safe. And or if factor of safety is actually less than 1. Okay, in that case, you know the part is not safe. Or the way I like to call this, does not meet requirements, right? Doesn't meet would say it does not meet requirements. Okay, so that's what it could mean. In such a case, when it fails, in some cases you just have to check the part. In many other cases, then you may have to go your second philosophy. That's here. The extent of the discussion of your textbook, most of these classes, is this part right here. Just check if it's going to be safe or it's going to fail. That's not the extent of the class as I have outlined for you. The extent of this class and every topic we're going to do is we're going to learn how to design the part. Because in the industry, real life, this is what we really want to end up doing at the end of the day. And what you're going to do is you're going to iterate between material selection, your sizing, boundary conditions or loads. Typically, this is given and this is given, and you just are, if you want to say, I'm going to keep the material the same, then you just work on sizing. In many other cases, you can choose another material, and these are not an option. In some cases, this may be an option. So when I'm doing a design of the part, I want to bring the factor safety as close to 1 as possible, but I want to still keep it bigger than 1. That's for an example. I'm doing a part design, and I find that factor safety is equal to 1.23. Okay, it's safe, but if you just go and say my part is safe, and you stop right there, well, you have now created a part with extra size, extra heavy that I may not necessarily need. It depends on application to application, but in the general sense, what we want to do is we want to keep redesigning this part until I can bring this factor of safety very close to 1, but has to be bigger than 1. Why do I say, bigger than 1? Why I say bigger than 1 or equal than 1? Because your factor safety, if it's equal to 0.999, I may not like that, okay? Even that rounds up to 1. So you want to have probably a factor safety 1.002, that may be even still better. So that's why it means it has to be 1 and bigger than 1. So keep that in mind as we do all the designs in this course. Everything that we will be designing will have that philosophy embedded into it.